In this question, we would like to prove that n brackets n squared plus 5 must be an even number. And when we start off with this proof, it directs us to think of an even number. So we should be thinking about splitting our answer up into odd numbers and even numbers and looking at those both separately. What we'd like to show is that if n is an odd number, this must be even, and if n is an even number, this must be even. Let's start with the odd numbers. So if n is an odd number, well, in these proofs, if something's an odd number, we always call it 2k plus 1. So let's write this out with 2k plus 1. N becomes 2k plus 1. N squared will be 2k plus 1 squared, and we need to plus our 5 on the end. Well, now let's play around with this expression and see what happens. We can leave our 2k plus 1 alone for now. And when we expand this thing, 2k plus 1 all squared, we get 4k squared plus 4k. We have a plus 1 on the end, and we also need to add this plus 5. So you could add this in another step, but I'm going to skip this step to just make it a plus 6. Plus 1 plus 5. Okay, well now we might be getting somewhere. We'd like to show this whole thing is even, and we've got a really good idea to use here. That 4k squared plus 4k plus 6, all of the coefficients in this quadratic are even numbers. What that means is we can pull an even number, a factor of 2, out of this thing. So let's do that below. We've got 2k plus 1. And here we can take out 2. And we've got 2k squared plus 2k plus 3. This is so key for us to understand that any even number times by anything has to be even. You can't escape the even numbers by timesing them by any other whole number. So because we've got this 2 here, that means the whole thing must be even. So we can say here, therefore, n brackets n squared plus 5 is even if n is odd. So we've showed one part of what we'd like to show. N brackets n squared plus 5 must be even if n is odd. Now let's look at the other case for n, because n could also be an even number itself. So the second part is us looking, well, what if n is even? This one's actually easier to do, because if n is even, we can just write it as a number like this, 2k. And our n squared plus 5 is going to become 2k all squared plus 5. At this point, we don't even need to bother expanding this, because whatever's in those brackets, we're multiplying it by a 2k at the front. So whatever we've got, we have to have this factor of 2 in there, and because we've got a factor of 2, that means n brackets n squared plus 5 must be even in this case. So we can again conclude, I'll do it in this colour, therefore n brackets n squared plus 5 is even if n is even. So at this point we've showed it's even if n is odd, and it's even if n is even. A good habit though to finish off our proof is just to say, therefore it's true for all the natural numbers. So therefore, again we can use our 3 dots, n brackets n squared plus 5 is even for all, and I'm going to use this fancy upside down A. That means for all the n's which are contained within a set of natural numbers. That's how we can conclude our proof.